So I'm going to be recording part D of my Avogadros number project for physics. So for the first slide, we have relevance of problem. My new problem relates to Avogadros number because it uses the same idea we learned in earlier parts of the project, counting numbers of particles in a substance before we worked on examples, showing how 1 mole has 6.022 times 10 to 10 raised by 23 particles. My problem is similar, but it uses different number of moles. This makes it a new situation that still follows the main concept. This problem requires real numerical solvings because you have to multiply the number of moles by Avogadros number to find the total of numbers of a molecule. It is not fill in the blank or multiple choice question. You need to do actual math steps, which helps understand the topic better. So we have, benefits of the problem. Understanding this problem is helpful because it shows how to use Avogadros number to find the number of particles in a substance. It makes the idea of moles and numbers easier to understand. By solving this problem, a person practices multiplying large numbers using powers of 10 and applying formulas step by step. After solving this problem, a person could solve other problems like finding the number of atoms in a compound, the number of molecules in a gas, or calculating the numbers of particles in different amounts of substance. For the third step, we have development of problems. I made my problems from scratch by choosing number of moles, 2 moles, and asking how many molecules are in that amount. Then I used Avogadros number to turn it into a real math problem. This problem is not too simple because you have to use the formula by multiplying it by a very large number. You also need to handle the powers of 10 correctly. This math problem is not too hard because the steps are clear and only one formula is used. The numbers are easy to work with. It was a little difficult to write the problem because I had to make sure it was new and not the same as the textbooks or online. I also avoided making a multiple choice or just a definition question. Yeah, that. I needed real calculations to solve this. So the uniqueness of the problem, this problem is different from textbooks or internet problems because I picked my own numbers of moles instead of the usual 1 mole example. It is new and not copied. Most common problems are very simple and use the same examples. My problem uses different numbers and asks for total number of molecules, which makes it unique. I added my own numbers to make sure you have to do real calculations. This makes it more original and useful to practice. This problem goes beyond common examples because it helps students practice multiplying by Avogadros number in a new way. Formula for my problem. Main formula: n equals n times Na. Variables: n equals number of particles, which is atoms or molecules. The smaller n equals number of moles. The constant, I don't really know how to read that, but there it is. Units: smaller n in moles, and big N is number of particles, Na in particles per mole. Here is my visual for the problems for slide 4. And you can see I made a table to show the number of molecules changes with different numbers of moles. An explanation of the data: when the number of moles increases, the number of molecule also increases. The relationship is linear because doubling the moles doubles the number of molecules. Each point shows how the same formula works with different amounts of substances. Yes. Here is the solution for my problem. Problem is 2 moles of water. Find the number of molecules. So you can see right here. Alright, so the formula. Here's the formula. I don't know if you can see that. Alright, so step 1, write the known values, which is n equals 2 moles. Step 2, multiply. You can see that. And step 3 is answer. They're about 1.20 times 20 to the 24. Verification for my problem. We check the calculations. Just close up. Okay. The math is correct, hopefully. The answer is reasonable. 1 mole has 6.022 times, let's see. Okay, 10 to 23 particles. 2 moles should have about twice that, which is, there's the number. Units are correct. Number of particles. The problem is useful because it shows Avogadros number links moles to the actual number of particles.